Hi everyone, welcome back to another episode on Databricks. And this session we talk about window function. We talked about normal functions in one of my previous session, and I will provide the link to that video in the description. So we can talk about different window functions available in Databricks. We have ranking function, analytic function, and aggregate functions. So window functions introduced in Spark, I think in 2014 or 2015, and these functions were available in SQL Server or Oracle long back, right? So these functions, window functions, are very useful for analytical usage, and which was very difficult before the implementation of Windows function. So to use Windows function, we need to use over, partition by, and order by clauses. We will go and check what exactly these keywords and how useful it is, and where exactly we can use Windows function. To demonstrate Windows function, initially I thought I'll use any freely available dataset. But it's a very simple concept, so I thought, okay, let's go for static datasets. So the first step to demonstrate this one is preparing the data. So for that, I choose four fields starting from product, quantity, sales amount, and finally state. So I have similar kind of products in different states. Virginia, Georgia, and New York, right? So this is my data, and this is the schema that I am going to give for this data. So which is one is string, another one is integer, third one is integer, and finally again string. Now this list I'm converting into Spark data frame. How I can create it? It's like a Spark create data frame. Data equal to the sales data, that is the list I created above, and apply the schema, that is this line. So let's execute this, and okay, let me display the values that will give you display. Okay, here is the data that we are going to use for this demo, and it's very simple. We have enough record that is required to demonstrate this. All right, so we start with the ranking function. So we have a rank, dense rank, a row number. We'll see what are these three functions and how benefit for you when you do the data analysis, right? So first one, we will check how we can implement rank. So rank will give you the ranking of certain data based on the partition that we provide, and based on some certain amount or the quantity or any other criteria. So basically we are ranking the data for each and every row, we are ranking it. So to use ranking, we need to import rank function from pyspark.sql.functions. Okay, and in order to use window function, we need to import window. Now this is the window specification that we are going to use in this particular ranking example, right? So window.partition by state. I'm going to partition the data based on the state, and I need to understand what is the highest ranked product in each state. Highest ranked based on what? Sales amount, right? So you can, this is the keyword that you use to partition the data based on the column name. In this case it is date, then dot order by sales amount. So which product give you the most amount, that we need to consider as rank 1. So in order to get the highest value, I made it as DESC function, right? So the order by sales amount DESC. So this will give you the highest sales amount value. Now how we can apply that? For this data frame, I'm going to add a new column, that is sales DF, that we got it before this data set. I'm adding one more column and name it as rank, and use rank function, open bracket, close bracket, dot over based on the Windows spec. Either you can give this completely here, or you can provide this Windows spec string here. Right now, let's execute and see how it works. I forgot to import the ESP function, so yeah, now you can see the result, right? So for Georgia, I have 4 records, and all these 4 records are ranked based on the amount. So here is the 1300 is the highest amount, then 550, then 480, then 240. Similarly, if you look at New York, we have 1100, 530. So this is how you can use rank. So there is a slight difference between rank and dense rank. So let's go and check what exactly dense rank will provide you the result, right? So it's very simple. Instead of rank, I'm using the same statement, except that here I'm going to use dense underscore rank. Let's execute this. Look at the data result, right? So here we have 1 2 3 4 and 1 2, so there is no difference, right? But in order to show the difference, what I did is I added same data here. So if you look at these two data, the data point is same, like a quantity is 40 and sales amount is 987. So we can go and check what happened to those records, right? So let's go to rank and we'll take Virginia. Now you can see these two are 1, correct? And the second the third one is like 500 sales amount, but if you look at the rank, it comes around third. It's not like 2. So 1 1, instead of coming 2, it is displayed as 3. Whereas if you look at dense rank, come to Virginia, you can see 1 1, and the actual second is named it as 2 instead of 3. So that's the only difference between rank and the dense rank. So dense rank will be continuous numbering system, whereas rank, it will skip the next number if the subsequent record is matches with the current one. Okay. Next, we can look at row underscore number function. So unlike rank and dense rank, row number just generate the unique records for the partition. It will not consider the rank of each record based on certain value. That's the only difference. So let's execute this statement and compare the result, right? So here you can see every record for the partition, it given the ranking system 1 2 3 4, and also we can check the Virginia partition where we have the same number of same value
for multiple records. So this is the same value 987, 987. In rank function, it is given 1 1, and even dense rank also given 1 1. But here it is continuous numbering system. So wherever you want to give a unique value to the partition, we can use row underscore number. Okay. Now we'll go to analytical functions. Lead and lag are another two function that is used for the analytical purpose, right? So if you want to make use of lead and lag, again you need to import those functions from the SQL dot functions. So I added here. So either you can import all the functions at one shot, or wherever whichever cell is required that function you can import it. But I imported at the beginning, so you don't need to import it again and again, right? And I used lead and lag in the same data and the same statement, so that it will be easy for us to understand, right? So it is the same data I used, same partition I used, the state, and here it is a sales amount, order by sales amount, DAC. And if you look at the first row, right, for product 001, quantity we have 10, sales amount is 1300. For Georgia state, the max next value is 550. So if you look at the second row, it is coming as 550, right? That came in the same record, same row here. And the previous value for this one, we don't have any previous value, that's why it came as null. So any calculation that requires the previous row and the current next row, that is required to include in the same current row of value, then you can use lead and lag. So this is how you can use a lead and lag function. All right. Now our normal aggregate functions, we normally use so many min, max, average, sum in day-to-day life, right? So this is common, but only thing is here we are using window function and calculating these aggregate functions for the partition. And if you execute, then I can explain this more. Like here, if you look at the sales partition data, this DF, I have added total sales. For that, the sum of the sales amount, right, for that partition. So how it calculated for the partition, it will sum up 1300, 550, 480, 240. So together we got 2570. So this total sum for that state will appear in each row, and then we can go for the percentage, or any other calculation for each row, right? And same way for some, I also calculated average and minimum sales. So minimum is 240. So you can see these are the total number of records we have, and 240 is the minimum one. Now I was not able to calculate this percentage in the same line as others, because the total sales is required for this calculation. So this total sales is available for this data frame, or you need to use this calculation inside the total logic. You need to use it inside here. So I don't want to make it that much complex. That's the reason I created another data frame and calculated this total sales. That should be fine, because this will be, if you keep like this, your code will be maintainable very easily, right? That's the reason I split it out. And also, you don't need to provide this window spec here. As I told you before, you can just directly copy this one and replace this window spec. This also will work out. But why we added as a separate string, that will be very easy for maintaining, right? So I'll take back to the normal. Yeah. Now here how we are doing. So we got all the required data to calculate percentage of sales in the data frame. Then we can make use of this formula, right? Sales amount divided by total sales. So we have 1000 divided by 2570 into 100, that will give you the percentage. So this is how you can calculate the percentage using aggregate function. All right, so here is another example where we can make use of aggregate function, right? So in this scenario we are finding the differences in sales from the highest performing product in the same state. So with which each row we are calculating the differences. So let's execute this and see the result, right? So here you can see 1300. This is the highest performing product for this particular state. Again, here it is partitioned for each state, right? So 1300 minus 1300 is 0. Here again 1300 minus 550, it is 750. So 750 is the uh, differences of amount between the highest performing product and this product. So how we created, so it's the same thing, we created partition based on the state, order by sales amount. This is actually not required, but I just kept it here. Then the revenue difference is maximum sales amount over the same window spec minus the sales current sales amount. So then we will apply this revenue difference here. So sales difference is another data frame, sales diff dot select. I'm going to select all the required fields here. Then the revenue difference, right? So either the same way, window spec we are keeping it here instead of adding here in this place. The same way we created the revenue differences separately and applying here. We can directly use this statement completely here. Instead we are just adding it here, as I said, just for the code maintainability, right? Okay, so if you have any question, feel free to comment below and I will reply to your questions. Thank you. If you would like to receive more such videos, please like and subscribe to my channel. Also, if you would like to connect with me, I have provided my details here, my email and LinkedIn. So thank you very much.